Welcome to case study number 1, hydrocarbon systems. What are we going to learn here? Essentially, we're going to learn the basics on what is an environment, how to open a simulation, how to open a new simulation, blank simulation, save them, how to create backups, what are the several files that Aspen Plus will create once you are either creating, opening, making backups, saving templates and so on. Then we go to the setup. We are going to learn how to set up the physical property environment. Essentially, we're going to cover two main environments: physical property environment and the simulation environment. So in this specific case study, we're just going to learn how to set up properly the minimum requirements for a physical property environment, which is a component list of all the hydrocarbons that we're going to be using, how to find them, how to search for them, how to remove or add existing materials, and the property method, which is essentially the thermodynamic package that we're going to be using, how are the properties going to be calculated, how they're going to be mixing rules, also what are the activity considerations or the equation of states. Now we pass, once that we set up the physical property environment, from now on you will be able to go directly to the simulation environment. One of the most important parts on the simulation environment is the flowsheet. The flowsheet is essentially where we are going to add all our unit operations, all our streams, where we are going to be working the most of the time. First things first, I'm going to show you how to add streams and how to add unit operations. Then we're going to see a little bit on flowsheet manipulation. How can you be able to move easier or manipulate the flowsheet in order for you to understand what's happening with the simulation. We're going to be adding these labels: temperature and pressure flow, vapor fractions. You can also even add heat duties, work duties. Whatever type of simulation you're doing, you should always add what is convenient for you. For instance, flow, if you're working with moles, add flows of moles. If you're working maybe with volume, you're going to be interested in working with volumetric units, or if you're working with mass, add mass units. Then we go into more manipulation of the streams, how to reconnect source, destination, how to break them, how to reconnect, how to move, and how to manipulate the blocks. We can always change the physical appearance of a block, even though the simulation will still consider this a block. For instance, if we're talking about a mixer, even though you're saying this is a tea mixing, or this may be a tank of mixing, or even just a physical point, for Aspen Plus, the mixing unit is always the same. This is just for us to understand, to see if we're working with a T unit that maybe two streams come here and they mix. Maybe you know that in real life you have a tank, mixing tank, or maybe you just want to represent this mixture with a point. Whatever you're using, Aspen Plus still is using the mix unit. The same is true for the splitting. Whenever you're talking about splitting, we must use F-split, which is the common splitting pattern. You should either add the percentage of splitting. No, don't worry, we're going to see that in the simulation. Also, we're going to be working with heating, how to set up our heater in order to either select vapor fraction, pressure, temperatures, heat duties. Then we will see this part right here, which is very important, is the separator units. SEP1 and SEP2 are actually not thermodynamic based separators. These are used whenever you know that, for instance, if you're modeling a black box, you don't know what's happening there, but you still know that you have an outlet. 30% of hydrogen is going here, 70% goes here. You don't know how to model that, but you still need to model that. You can use this. For instance, a membrane, it's also very commonly modeled with SEP1 or SEP2. And then we're going to be working with the flash. A flash is nothing more than a drum that separates liquid and its vapor fractions. We're going to be using flash number 2 drum for Aspen Plus. And then we're going to be working a little bit on the pressure sides with valves. Valves are used to decrease pressure and maybe even we add pumps or compressors to be working with the pressure. We're going to be learning about the variable types. It's very important to understand that certain inputs are required, others are optional. The more you add, then all this is playing with the number of degrees of freedom. If you add plenty of input, then several output cannot be changed. For instance, if you're talking about a heater, you have a flow rate, which it has a temperature, a pressure, and a duty. You will not be able to select the outlet temperature because you already have a duty. And the reverse is true. You have the outlet temperature, inlet temperature, you know the mixture. By definition, you can solve for the heat duty. So this is how we're going to treat inputs and output variables. We're going to see how to run the simulation, how to click the beautiful next button, which will allow us to continue with the simulation in order to run with the least requirements in the simulation. And then we will see the most important part, which is of course simulate and try to get the results, analyze them, read them, what's happening, are we getting what we want, or maybe we don't know what's happening. This is a very important part because sometimes you gotta change the property methods. Sometimes you do not add enough components to your mixture, you forgot some component or so. Maybe you forgot how to specify the stream, maybe you specified incorrectly, you want to change from mass to moles, the composition was given maybe volumetric, you will want to check that out. And also, most likely what we want are stream results, the product results, what's happening, are we achieving our purity or not, and then we go and verify our unit results. For instance, if we're talking about the reactor, what is the heat duty, what is the conversion, the residence time, and so on. If we're talking about a distillation unit, you will want to see how much heat duty is required in the condenser, the reboiler, maybe the profiles. You want to see the pressure profile, temperature profile, composition profile, and so on. Okay, so let's start with our hydrocarbon system, guys. Don't worry, just follow the video lecture and everything is going to go fine.